my earlier video, I had discussed some question about linear algebra which had come different type of comparative exam. Today I will discuss some more questions which had come in different type of comparative exam. First question, which had come CSIR NET 2015 exam. The question is, be an n cross n matrix over the complex number C such that every non-zero vector of Cn is an eigenvector of the matrix A. Then option 1, all eigenvalues of A are equal. Option 2, all eigenvalues of A are distinct. Option 3, A equal to lambda I, where for some lambda belongs to complex number and where I is the n cross n identity matrix. Option 4, if chi A and ma denote the characteristic polynomial and minimal polynomial, then characteristic polynomial always equal to the minimal polynomial. Okay? Now let's see the option. At first just think, here every non-zero vector in Cn is an eigenvector. This is very important. We have to prove every non-zero vector is an eigenvector. For this, consider Ei equal to 0, 0, 0, and since here Ei in the ith position 1 and otherwise is 0, and consider Ei equal to lambda I Ei. For this, consider an arbitrary matrix A, where A equal to A11, A12, A1n, A21, A22, A2n, and this would be continue, and last term is An1, An2, Ann. Okay? Then Ei means, since Ei is this vector, then Ei means A1i, A2i up to Aii up to Ani equal to. Here lambda I Ei means, here in ith position is lambda I and otherwise would be 0. And that imply from this expression we can tell Ai equal to lambda I and Aj equal to 0 where j not equal to I. That means from this expression we can tell obviously the matrix A is a diagonal matrix. That means A is lambda 1, lambda 2 up to lambda n and otherwise is 0. So option 3 is a right option. A equal to lambda I, where for some lambda belongs to C, where I is the n cross n identity matrix. Option 1 imply all eigenvalue of the matrix are equal. Since here this is the scalar matrix, so option 1 is also right option. And option 2 imply all eigenvalues of A are distinct. This is the wrong option because here every non-zero vector of Cn is an eigenvector. This imply all eigenvalues are always equal. Option 4 indicate if chi A and ma denote the characteristic polynomial and minimal polynomial, then always chi A equal to ma. Okay? For this, A is a diagonal matrix. That means obviously A is diagonalizable. Okay? And that imply characteristic polynomial is A minus lambda I to the power n, where I equal to 1 to up to n. Okay? Since the matrix is diagonalizable, so obviously the minimal polynomial always would be linear factor. So characteristic polynomial is A minus lambda I to the power n, but minimal polynomial would be A minus lambda I, since the matrix is diagonalizable. Because when the matrix be diagonalizable, then always the minimal polynomial will be in linear factor. We all of us know this is. I have discussed this part in my previous video. So, option 4 is a wrong option. Okay? Are you getting? These type of question are actually very important for not only competitive exam, for higher study also. When every non-zero vector of Cn is an eigenvector, this part or this topic is very important for any competitive exam. Okay? Now I will see the new matrix, rank 1 matrix. Notice, here obviously rank of this matrix is 1. This all matrix be the rank 1 matrix. Okay? And rank 1 matrix is actually in linear algebra very nice property. Here always rank 1 matrix is singular. Now consider one matrix and notice obviously rank of this matrix is 1. So here dimension of row space is also would be 1, and also dimension of column space would be 1, since rank is equal to dimension of row space and dimension of column space. And here notice the linearly independent vector in the row space is 1, 4, 5. And notice here one thing, you can write this as 1, 2 times 1, 4, 5. This multiplication would be this A. Therefore, we can write any rank 1 matrix as UV transpose, where U be the sum column and V transpose be the sum row. This is the notation of any rank 1 matrix. Are you getting? OA. Therefore, I will get any rank 1 matrix by this notation, UV transpose, where U be the sum column and V transpose be the sum row. And this is actually the outer product, known as outer product. Means any matrix which is look like UV transpose is actually the rank 1 matrix. This notation is outer product because we all of us know, if we consider this vector u1, u2, u equal to u1, u2, u3 and v equal to v1, v2, v3, then inner product is look like u transpose v, which is actually, this is the look like u transpose v, this that means this u transpose means u1, u2, u3 and v equal to v1, v2, v3. And u transpose v would be here for inner product, we all of us know this is look like such type, and this would be 1 cross 1 matrix. But for outer product, this would be UV transpose. So by outer product, I will get here 3 cross 3 matrix, and this is the actual rotation of rank 1 matrix. Any matrix which has rank 1, we can write this notation. Are you getting clearly what is the inner product and what is the outer product? Why rank 1 matrix is called as outer product? OL. Now I will see one question about rank 1 matrix which had come CSIR NET June 2015 exam. The question is, consider a set S which is 3 cross 3 real matrix, says A, with the condition A transpose A equal to this matrix. Then the set S contains option 1 nilpotent matrix. Option 2, a matrix of rank 1. Option 3, a matrix of rank 2. And option 4, a non-zero skew symmetric matrix. Notice, here A transpose A means obviously this is the outer inner product. And I have seen outer inner product always imply rank 1 matrix. And notice, this matrix also rank 1 matrix. So, obviously, by this concept, we can tell S contains a matrix of rank 1. Are you getting why the concept is very important? Other option is A contains a nilpotent matrix? Notice, this is rank 1 matrix. So, obviously, by rank nullity theorem, we can tell nullity equal to, here would be 2. That means, obviously, this matrix is similar to one nilpotent matrix, which is such type 0, 0, 0, 1. Since here nullity equal to 2 means there exists 2 Jordan block. This is one Jordan block and this is another Jordan block. So, we can tell S contains a nilpotent matrix. This matrix is obviously the nilpotent matrix because the eigenvalue is 0. So, option 3 is a wrong option. This is a matrix of rank 2. Option 4 also wrong option. S contains a non-zero skew symmetric matrix. We all of us know rank of non-zero skew symmetric matrix is at least 2 because this is, consider A be 3 cross 3 non-zero skew symmetric matrix. Then obviously for skew symmetric matrix, we all of us know the eigenvalue is either 0 or purely imaginary. So, if lambda be non-zero eigenvalue of the matrix A, consider lambda equal to alpha I, where alpha be R minus singleton set 0, then their conjugate also be the eigenvalue of the matrix A. Therefore, the eigenvalue of the matrix A are 0, lambda and lambda bar. Therefore, since these two are non-zero eigenvalue, so obviously for this matrix rank is 2. Since here the rank matrix is 3 cross 3 matrix, so for non-zero skew symmetric matrix always contain at least rank 2. So, option 4 is a wrong option. Are you getting? Are you getting why the concept rank 1 matrix is very important? If you know the concept, then you can easily tell the option easily. Now I will say one question which had come GATE 2018 exam. The question is, consider VB a real vector space of all polynomial of degree less than or equal to 2 with real coefficient. And the mapping is such type T from vector space to itself with a linear transformation given by T of P equal to 2P plus P prime, where for all P belongs to this vector space and P prime be the derivative of this polynomial. Then number of non-zero entries in the Jordan canonical form is, here this is the linear transformation from vector space to itself such that Tp equal to 2p plus p prime, where for all polynomial belongs to the vector space. Then here the basis not indicate, so consider the standard basis. Then T of 1 would be 2 plus 0. T of x would be 2x plus 1. T of x square would be 2x square plus 2x. Okay? Then the matrix representation with respect to this basis would be matrix. Are you getting? And since this is the upper triangular matrix, so the characteristic polynomial would be x minus 2 whole cube. This is the characteristic polynomial. Then what is the minimal polynomial? Obviously 2 be the eigenvalue with multiplicity 3. Okay. Now how many Jordan block exist for this eigenvalue? Notice here the geometric multiplicity would be, we all of us know, 3 minus rank of a minus 2i, and rank of a minus 2i would be, a minus 2i would be this matrix, and notice rank of a minus 2i would be obviously 2. Therefore, geometric multiplicity would be 3 minus 2, which is equal to 1. Therefore, with eigenvalue 2, there exists one block, and the block is look like such type: 2 0 1 0 0 2 1 0 0 2. Since here only one block exists with respect to the eigenvalue 2, that means number of non-zero element in this Jordan block is 5. Are you getting how the Jordan canonical from this type of expression is very important for any competitive exam? So, I will highly recommend you, if you don't see my previous video, at first see the previous video. Then you will evaluate any question for any competitive exam easily. Okay? Okay. I will stop here. In my next video, I will discuss different type of question of linear algebra which had come, also different type of example. Because linear algebra are very important for any competitive exam and also higher study. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.